Okay, so now that we know about relational operators, let's go ahead and talk about logical operators. So we're going to name this thing, new class, logical operators. We want that thing to have a main method as well. We're going to finish that. Okay? And just like we did the last time, we're going to add some notes on here. So slash asterisk return. Java uses the following logical operators. Okay, so the first one looks like this. 2 ampersands, all right, and that stands for and. Okay, and allows us to compare two different conditions to each other and see if they're both true. Okay, so it says like the only way that this and is true is when both conditions that it's butted up against are true. Okay, the next one is or. Or looks like this. Okay, and if you look right under your backspace key, the farthest right on your keyboard, you got to hit Shift, and then that's where that vertical bar is. Okay, so that's for or. Or is true when either condition is true. The third one, and this is the last logical operator, is not. Okay, not is a little bit different. Not goes in front of a condition, and it just gives us the opposite of the result of the condition. Okay, so we'll get into some examples, but I just want to kind of finish up the notes up here while we're doing it. So it's important that you guys understand that there's an order of operations for these. Okay, and the way that this works is your computer or your language, the Java language, will evaluate these things in this order. It'll go relational operators first. Okay, then it'll pay attention to whatever grouping, like, so if you put like parentheses around something, it'll figure that out. Okay, then it'll do any nots that are in there, then it'll do and the last thing it does is ors. Okay, so the next thing we're going to do is I'm going to flip over here. Okay, this is the University of Wisconsin requirements and expectations for you to get into the University of Wisconsin. All right, so they want you to have 4 years of English, 3 to 4 years of foreign language, etc. But let's go ahead and look down here at some different things that we can look at. Okay, we typically see unweighted academic GPAs between 3.8 and 4.0 and a class rank in the 85th to 97th percentile. Now, if you have a 98th, 99th percentile, are you going to say, no, that's not right? No, okay? But what we're saying is, if my GPA is between 3.8 and 4.0, I've got a chance to get into University of Wisconsin, okay? So, over here, we're going to try to figure out what we can do to get that, okay? So we're going to say something like double GPA again equals, and if I use my other GPA that I had before, which was 2.89, right? Then we can do something like, say, system.out.print, okay? Accepted at UW equals, and then we're going to put in the condition down here in the system.out.print line, if I could type. All right. So it said over on that website, if you remember, it said GPAs between 3.8 and 4.0. Okay? So in that case, then what I'd want to do is I want to check to see if my GPA is greater than or equal to 3.8, all right, and my GPA is less than 4.0. I guess it could be equal to 4.0 too, so less than or equal to 4.0. All right? So if I run this one now, it says accepted at UW equals false, right? So 2.89 isn't going to cut it because it's not greater than or equal to 3.8, even though it is less than or equal to 4.0, okay? Both of those things have to be true in order for me to get accepted into UW-Madison, okay? And so the way the AND works here is it, first of all, the computer will evaluate GPA greater than or equal to 3.8. That's false. Evaluate GPA less than or equal to 4.0. That's true. Okay? And then both of these have to be true in order for the AND to return true or to evaluate to true. So if I change my GPA to 3.89, that'd be nice, and run it again, now accepted at UW is true. Is that making sense, guys? All right. So let's see what else we have here. Test scores. Typically score between 28, admitted students typically score between 28 and 32 on the ACT. All right? Or between 1330 and 1460 on the SAT. Okay? The highest you can get on the ACT is a 36. Okay, so let's go ahead and see what we can do over here. So 28 and 32 on the ACT. So let's go ahead and say that my int ACT score is whatever it is, okay? 26, okay? But what we really care about is the condition that we'd have to write for getting into UW, okay? So we're going to go ahead and say system.out.print, okay? ACT good enough. Equals. And then, man, wow. And then we said that we want the ACT to be greater than or equal to, what was it, 28? Yeah. And ACT less than or equal to, now they said typically between 28 and 32, but I bet you that if I got a 34 on the ACT, they'd be okay with that, right? So I'm going to say less than or equal to 36 because that's the maximum that I can get. Okay? So I think you guys can kind of understand, what is this going to print out right now? It's going to print out false, right? Because 26 is not greater than or equal to 28, and both of these need to be true in order for me to do that. Okay, so let's go ahead and put SAT in here. Let's go int SAT. Okay, I have no idea what my SAT score was, but I want to look back over here and see what the range was. So it's 1330 to 1460 on the SAT. Okay, so I'm just going to go ahead and say that I got a 1380 on the SAT. And then I'm going to copy this stuff. Okay. So I'm going to copy that using the keyboard and paste it in. And then I'm going to say SAT good enough. And then SAT had to be greater than, what was it, 1320? 1330 and 1460. So let's just say, for example, that like they're going to look at the ACT and they're going to look at the SAT and they're going to say, well, either one of those has to be good. Okay, so let's just do another one here where we're going to say system.out.print. Man, oh man. Okay, and let's just say that it's going to be like testing good enough. So we're going to combine those. All right, and so I'm going to go system.out.println again. All right, and now this is what I'm going to do. I'm going to copy what I have for the ACT right here, okay? So make sure you're kind of looking up here, okay? I'm going to copy that and paste it down here. And then I'm going to put OR, and then I'm going to copy my SAT. Okay, so it's kind of a long line of reasoning here. I got to put a semicolon in after that. All right, and then I'm going to run that, and it says accepted at UW equals true. That's because of my 3.89 that I changed it to. ACT good enough is false. SAT good enough is true. Testing good enough is true. So what it does is remember the order of operations, okay? It's going to evaluate each of these relational operators separately, okay? So this one, the ACT greater than or equal to 28 is false. ACT less than 36 is true. False and true is false, okay? Greater than 1330 for the SAT, that's true. Less than 1460 for the ACT, that's true. So that all over there is true. This false or this true gives me true, okay? Because either one of these things has to be true in order for the whole thing to be true, right? It's kind of a complex example. So there's a way that we could make it a little less complex, okay? So what I'm going to do is I'm going to comment this out. And instead of doing that, I'm going to go Boolean good ACT equals this stuff. And then Boolean good SAT equals the SAT condition. All right. And then I'm going to print out good ACT or good SAT. All right. And so now that's doing the same thing that we did up in the commented line, but it's just showing you that this is the result of the ACT is called good ACT. Okay, so that's going to be false. The result of this is going to be true. We're going to call that good ACT, or SAT, I should say. And then false or true is going to still print out true. We've been doing kind of some, goofy stuff here, but we're going to make it even more goofy now, okay? So we're going to go up here and we're going to say, like, the other thing that they care about is your favorite color, all right? So that's not true, but we're going to say color, favorite color, fave color equals, and I don't really have a favorite color, but let's go ahead and say that it's blue, okay? So color, fave color equals color.blue, all right? And then let's go down here and say that they'll let us in as long as our favorite color is red, okay? Because their color is red. So we're going to go down here and do something like system.out.print. Okay? And we're going to go like do not admit equals, and then system.out.println. Now, if we wanted to know if the favorite color was red, we would do something like favorite color dot equals, and then color dot red. okay? But that's if we want to know if their favorite color does equal red, right? If we want to know if it doesn't equal red, then we put an exclamation point in front of there, and that tells us it's not equal to red. Does that concept make sense? So the exclamation point just basically negates or switches, gives us the opposite of whatever this answer is. Okay? So do not admit equals true. Because I said my favorite color is blue, they're not going to admit me. I got to say that it's red. Otherwise they won't let me in. Okay? So favorite color is what color? Blue. Okay? That equals red. Does blue equal red? No, that's false. Okay? But not false is true. And so that's why we're seeing true getting printed out here.